Hi, my name is Haley Steinbach. I did problem number 12. So the first step in this problem was to find the partial derivatives. Uh, and how we do this is we treat the equation. So if I'm taking in respect to x, I'm going to treat y as a constant. So for our first one, for f of x, we're left with negative x squared minus y. If I'm taking it with respect to y, I'm treating x as a constant, and I'm left with 2y minus x plus 1. So the next step in this problem was to find the critical points. And to find the critical points, you have to set both derivatives equal to 0. So you have f of x equals 0 and f of y equals 0. And what I did there is I plugged in my equation from that. So I was left with negative x squared minus y equals 0, which I then simplified to y equals negative x squared. This way I'm able to plug that into the equation, into my next equation. So then I'm also left with f of y equals 0. So you're left with 2y minus x plus 1 equals 0. And that's a lot easier to plug our equation into. I also, just for the sake of simplicity, I just went ahead and simplified it to x equals 2y plus 1. But since I already had that y, I just went ahead and plugged that in. So next step was x equals 2x squared plus 1. Yeah. So then I subtracted x from both sides, so I was left with 0 on that side. And then I subtracted 1 from each side. So that left us with 1 equals negative x times 2x plus 1 in parentheses. I solved for x from there, so we had negative x equals 1, so x equals negative 1. And then you take that 2x plus 1 and you set that equal to 0, and you're left with x equals 1/2. And then from there, to find the y coordinates of my values, I plugged those in. When I plugged in I plugged that into my f of x derivative equation. So I am then left with y equals negative 1 when you plug in negative 1, and y is negative 1/4 when you plug in 1/2. So our critical points are negative 1, and 1/2, and negative 1/4. So then we took our second partial derivatives, and that is taking our derivative with respect to our variables once again. So f of x, that would be taking the first partial derivative in respect to x this time. So you're left with negative 2x of fx of y is taking the x first partial derivative and taking it in respect to y. So following the same what we did before, you're left with negative 1. Same with fy of x, what you're doing there is you're taking y in respect to x. Your first y derivative in respect to x, so you're left with negative 1. Then your last one, we're taking the fy derivative and taking in respect to y once again, so you're left with 2. Then we do our determinant test. The determinant test is going to tell us if we have a relative max, minimum, or saddle point at our critical points. So what we're going to do is we're going to plug this in. We put them into our quadrant, then we do our multiplication. If our value is greater than 0, it is a maximum. If it is less than 0, it is saddle point. If it is 0, it is a minimum. When I plugged in negative 1, I got 2, which means it's a maximum. And I got negative 3 when I plugged in 1/2 and negative 1/4, which makes it a saddle point.